Welcome to Excel Business Statistical Analysis, video number 1, where we talk about data and statistics. Now, this is a Highline College Business 210 statistics class, and we're going to be using Microsoft 365 Excel. Now, this version is the best version in history. However, most of the calculations and reporting and charting that we do in this class can be done in any version of Excel. Now, here are all the topics for Chapter 1. Here's the topics for video number 1. We'll cover the folder and files for this class. Then we'll talk about data analysis, data and tables. And then we'll cover what is statistics. Now, we're going to start with folders and files. And down here, this is called the taskbar. And if you hover over that folder icon, you can see this is called File Explorer. Let's click to open. Now, on the left, you get to select the location where you're going to create folders and save files. If this is your computer, you get to select whatever location you want. If you've checked out a computer from Highline, then you need to plug in your USB drive and select that location. I'm going to use the desktop. And then over here, I want to create a folder. But before we do that, I want to go to the View tab. And notice that looks like an Excel file, and this looks like a Word file. But I don't see the extension. And for this class, you're going to need to come up and check File Name Extensions. And when I check this, now you can see the .file extension. We can have Excel file extensions such as .xlsx, .xlsm, .xls, and a bunch of others. The one we're going to use in this class is .xlsm. And here, this is a Word document, so you see .docx. Now, I want to create a folder here. You can go to the Home tab and use New Folder. Or you can use the keyboard, which shows up in that screen tip. And I'm going to use that keyboard, Control-Shift-N. And we want to name it, and you're going to put your name, Business 210 Excel Statistics. Now, where it says your name, you're going to put your name, not my name, your name, and then Enter. Now, over here on the left, I can select this folder, and I'm looking inside, and there's nothing there. But later, you're going to have lots of files, and all the files you use while you're watching the videos and doing your homework problems, you're going to save those, because later you can use those to look things up when you complete your tests. Now, let's go to our People website. There it is. This is not Canvas. This is our People website. This is where we get all of our files and click on the links to watch the videos. Now, I'm just building this class right now, so the only link there is for Chapter 1. I'm going to click on this. Up at the top, that one Excel file right there is the file you're going to use while you watch the videos. So you'll open it and then click on the link and watch the videos and follow along. Now, this file here is for a homework problem. So after you watch all the videos, then you jump over to the textbook, read the textbook, do the homework problems. All right, so I want to download this Excel file. Right-click, Save Link As. I'm using the Save As dialog box, just like Windows Explorer. I'm going to select Desktop, select my folder. Once I have it selected on the left, we can use this file name. There's the file extension. Then we click Save. I am not going to click this to open it. I want to go back to Windows Explorer, so I'm going to click this icon, selecting whatever the location on the left is. Now I'm going to look at the file and open it. Later, when you have lots of files, you can come back to any one of these files and simply double-click to open it. Now, when you open the Excel file, this Worksheet tab is showing. Now, next video is when I'll introduce Excel and how to navigate through Excel. All we're going to do in this video is we're going to use Excel to click on Sheet tabs and look at some definitions of terms we're going to use in this class. So I want to take my cursor and click on the Data and Table Sheet tab. Now, before we even define what statistics is, we actually have to define the broader category, data analysis. And the definition is convert raw data into useful information to gain insight and make decisions. If we click on the Sheet tab, what Excel does, here's a simple example. Here's some raw data. It's a bunch of revenue numbers. And if we need to take all those numbers and convert it to an average that we can use in a budget, that's an example of data analysis. It's also an example of statistics. We can also take this data set with a bunch of revenue numbers, create a tabular display or a graphical display. Here, we've created an insight about customer behavior. We can, from this chart, say that 86.5% of the customers spent less than 125 bucks. All of this is data analysis and statistical analysis. Now back over on data and table. But here's the thing. Data analysis has many synonyms. Data analytics, business intelligence, statistical analysis, mathematical analysis, and of course data analysis. Now this definition right here holds for all of these. If we just add using statistical techniques to the beginning of this, then we have the definition of statistical analysis. If we add using mathematical techniques, then we define this. If we say using business data, then we're talking about business intelligence. If we say using statistical, mathematical, or just data analysis techniques, then we're defining data analytics or analytics. So when you're out there working, you can hear any of these, and they all mean the same thing. Take raw data, convert it into useful information to help make decisions. Now, before we can move forward, we have to define things like what is data, what is a table. This is an example of not raw data. The bits of data are separated by a comma and stored in a single cell. Now, although it's common to get data like this, before we can analyze it, we'd have to break it apart into individual cells. Down here, this is raw data. On this particular day, for the publicly traded stock Google, this was the closing price for stock, and this was the volume for that day of buying and selling stock. So this is the raw data. But what are these? We need to scroll down here. You can use the scroll bar over here or the wheel on your mouse. You can also use the scroll arrow. What's a proper data set? Sometimes called a data set, sometimes called a table. A table is made up of fields. Those are the columns in the table. Here's the date field, close price, volume, and company. Field name. That's the name at the top of the field that describes what goes into the field. Date means you're only putting date in this column. Close price goes in this column. Volume and company. Now, what's so important about field names is that all the data we're going to get is going to be in a field. And the tools that we use, like a pivot table, Power Query, sorting, filtering, they all communicate with this data set based on field names. And a record, that's one row of related data in a table. This is one record. So on the 25th, Google, their stock closed at 2,775 and had a volume of 1,054,000. Now, the table requirements in Excel, the first two of them are universal for all tables of data that are stored anywhere. But in Excel, there's a third one. The first is field names must be in the first row. The second one is all subsequent rows are related data stored in as a record. And the third one is that empty cells or Excel column row headers must be all the way around the table. So these are Excel row headers, but notice there's empty cells. And I even have a little, because I didn't want this data to touch it, there's a little teeny completely empty column here. If you put a rogue piece of data like a note right here next to your table in Excel, it becomes part of the table, and it makes using the tools like pivot tables, Power Queries, sorting, filtering, and so on difficult to use. So no notes next to your data sets. Now next, I want to zoom out. If you look down here, this is called the status bar. And right there, you can slide this. Right now, it's at 190. So we want to scroll it down to a smaller percentage. Now, you can use the scroll bar right here, or you can hold Control and roll your wheel on the mouse. So I'm going to hold Control and roll my wheel. And I'm going to scroll down just a bit. Now, we already defined raw data, which is the bits of data stored in its smallest form. The textbook defines data as facts and figures collected, measured, summarized, and analyzed for presentation and interpretation. The facts and figures collected, that's the raw data in a table. When we measure and summarize, that means we make some calculation like the PE ratio for Google, or down here we went from this raw data, got a unique list of company names and calculated the mean, population standard deviation, and sum volume. Each of these is a calculation or a summary or a measurement. And then from the facts figures that are measured and summarized, we can analyze and then present and interpret. For example, down here we have a tabular presentation, and we can use the PE ratio, price to earning ratio, for a particular stock to interpret it and make a decision whether we want to buy the stock or not buy the stock. Now, a table is defined as field names in the first row, records in subsequent rows. Now, this is a table of raw data. This is a particular type of table where there are elements in the first column, and elements are a unique list of entities on which variable data are collected. Now, each company name is an element in this element field. A variable is defined as a characteristic or attribute of interest for the element. There are 5 variable fields in this table: ticker, year incorporated, industry, number of employees, and PE ratio. Now, there are 6 fields in this table, 1 element field, 5 variable fields. And for each record, there are 6 cells, 1 element cell, 5 variable cells. An observation is defined as the variable data for 1 element. So here's the observation for Google. And the book defines measurements as measurements are made for each variable to provide data in the observation. For example, loosely speaking, we went out and looked up the ticker, year incorporated, and industry, and measurements as we typically think of them: counted the number of employees, calculated PE ratio, and down here we made mean, standard deviation, and adding measurements. Now, we want to go over to the sheet data terms. Now, we need to talk about the different types of data so we understand what calculations could be done on certain types of data and what presentations can be done on certain types of data. Broadly speaking, there's 2 types of data. Categorical data means data grouped by a category. And with this type of data, you either have nominal or ordinal data. Now, nominal data has a category, but there is no rank. If we're looking at phones, iPhone, Samsung, or eye color, brown or hazel, there's no rank to that data. The calculations that we can make on nominal data are counting. That's it. Once we get the counts, then we can calculate percent of total based on those counts. So from our phone column, we have 2 possibilities, iPhone and Samsung. We get a count of 3 for iPhone, 1 for Samsung. If we calculate the percentages, 3 compared to a total of 4 is 75%. And for Samsung, it's a count of 1 and a percentage of 25%. That's all we can do with nominal data. Now, when we jump over to ordinal data, we have a category, but now we have a rank. But we don't know the distance between each rank. If we look at rating of a teacher, bad, good, and great, that's definitely a rank, but we don't know the distance between bad and good and great. The calculations we can make on ordinal data are counting, percent of total based on those counts, and if we have a number that represents the ranking category, like for rating of a teacher, then we can calculate an average. If we add all of these up, we get a total of 8. Divide by 4. The average rank would be 2. Now, quantitative data just means you have a number. And there's 2 types, interval and ratio. With interval, we have a rank. We know the distance between each rank. And 0 is either not in the scale, like IQ scores, or SAT scores, which go from 400 to 1,200. Or 0 is just a point on the scale like Celsius or Fahrenheit temperature. The calculations you can make are you can count, calculate percent of total based on the count, averages, differences, but ratios are not OK. And the reason is because of the number 0. Here, 0 isn't even in the scale, and for Fahrenheit temperature, it's just a point on the scale. If you take 20 degrees and divide it by 10 degrees and get 2, you cannot say that 20 degrees is twice as much as 10 degrees. Similarly over here, you cannot take the score 1,180 and compare it with division to 590 and say this student did twice as good as the student with 590 points. However, if we jump over to ratio level data, we can rank this data, and we know the distance between each rank. And this level of data involves scales where 0 means nothing exists. When you have no money, that means no money exists. Kelvin temperature, that actually does start at 0, and it means no molecular kinetic energy. And of course, for a score on a final that goes from 0 to 100, 0 means nothing exists. And of course, now we can do all these calculations, including a ratio. Using division, we can definitely say 12,000 is twice as much as 6,000. And going this direction, we can say, hey, moving from 6,000 to 12,000, that's a 100% increase. All right, so categorical data, we have nominal and ordinal. Quantitative data, we have interval and ratio. And knowing the differences between these will help us figure out the right calculation to make for the given type of data. Now, if we scroll down and over and zoom in a bit, there's a few more terms for data. Now, when we're talking about numbers, we have discrete numbers, and those are counting numbers and have gaps between each successive number. So for example, 1, 2, 3, or 1.2, 1.3, and so on. Discrete data answers the question, how many? Continuous numbers can occupy any value over a continuous range and depend on the measuring instrument, like time, weight, temperature, money. Now, dollars don't seem continuous because we have pennies, but many statisticians treat it as such. When you have a continuous variable, it answers the question, how much? Now, knowing the difference here will help us with things like what type of column chart to create for our data. There's also cross-sectional data and time series data. Cross-sectional data is data collected at the same or nearly the same point in time. This data set for our companies contains cross-sectional data. On the other hand, time series data is data collected over time. This time series data collected for this Excel line chart shows Amazon's stock price over a 5-day period. Now we next want to go talk about the definition of statistics. So I'm going to click on the Statistics Sheet tab. Now the definition of statistics, well, there's number facts like the U.S. unemployment rate reported in January 2021 was 6.3%. Surad Kulinator, a student, ranked at the 90th percentile for the test. Third quarter YouTube advertising revenue was $7.2 billion versus $7.4 billion expected. 6.3, 90th percentile, 7.2, and 7.4 billion. Those are all numbers that are statistics. But the subject of statistics defined in this textbook, statistics is the art and science of collecting, analyzing, presenting, and interpreting data. Now, wait a second. Art, science, how do those work together? Well, if we go over to the sheet art, now the science side of statistics is when we take raw data, create useful information to make decisions. We're not just going to guess about what the shape of our retail sales data is. We built a histogram, and here, based on evidence, we can clearly see most of the sales are for a small dollar amount. Now, when we build a histogram, we have to do a bunch of steps, and deciding how many classes, that's the art side of statistics. There's no exact formula for deciding whether I want 6, we can see the histogram change, or 12. It takes practice. It's a judgment call, and that's the art side of statistics. So here we have an example of the science and art of statistics working together. Back over on statistics. Now we'll do two types of statistics in this class. The first one is descriptive statistics. That's data that's summarized and presented. Tabular, that means a table of information. Graphical, charts, graphs, visualizations. And numerical, some measure or calculation like average, mean, median, and mode. If we go over to TGN, there's the raw data. And down here, and for descriptive statistics, we have a tabular example, a numerical example, and a graphical example. Back over to statistics. Now, inferential statistics is the process of using data obtained from a sample to make estimates and test hypotheses about a characteristic or attribute of a population. Said in a different way, we'll take a sample from a population and draw a reasonable conclusion that can help us estimate the unknown future. Now, population just means the set of all elements of interest in a particular study. Most of the time, populations are too big, so as a result, we have to take a sample, a subset of the population. Now, let's look at an example of inferential statistics over on Example of Inferential Statistics. We'll do this example in Chapter 9. This is a production example where a machine is filling boxes of cereal. And we will go out and sample box weight to see if the filling machine is filling correctly. Now the data is down here, and we'll do some techniques to help us infer from this sample something about the population. From our sample data, if we see a p-value, and that's the blue value here, that's bigger than the gray area, which is the level of significance, then it looks like the machine is filling correctly. Now I'm going to hit the F9 key because I have this data automatically randomizing. And we hit the F9. I could still see a sliver of blue there. F9, F9, uh-oh. Now from our sample data, we can infer that the machine is not filling correctly. So we have to go out and adjust the machine so it is filling accurately. This is an example of inferring from our sample data something about the population. Inferential statistics. And we'll do a lot of it like Chapter 6 and after. All right, in this video, we defined statistics. We looked at various data terms like categorical and quantitative. And we talked a lot about raw data, data, tables, and measurements. Now, next video, we'll get an introduction to Excel. All right, we'll see you next video.